RHS Pre-Calculus presents Using the Law of Sines. By the end of this video, you will understand how to use the law of sines. Daniel and James are two spies working for the CIA. They are in the Soviet Union and they have gathered intelligence that is greatly needed by the American government.
Daniel's in a city with codename Alpha, while James is in Beta. We'll abbreviate these as Point A and Point B.
Daniel and James need to get from their respective cities to City C, where they will trade information and check in with their spy headquarters. Both Daniel and James will be flying in on their radar-protected planes.
They know the distance between their two cities, City A and City B, is 20 miles, and James knows the distance from City B to City C is 15 miles.
When Daniel faces City B, City C is 30 degrees to the left. Daniel doesn't know how far away the meeting point is, and while James knows how far he needs to fly, he doesn't know in which direction he needs to go.
Let's help them use the law of sines to figure out the angles and distances they need to fly at.
This is the basic equation for the law of sines. This can also be written as 3 separate equations. When should you use the law of sines? Well, you should use it when you have the lengths of 2 sides and an angle of a triangle, and you need to find the angle that's across from a known side.
You can also use the law of sines when you have 2 angles and one side, and you need to know the side opposite a known angle.
In either situation, you have to already know one side and one angle that are across from each other. If we plug in the information we have, then we know the sine of A and the length of A, and we also know the length of C. We can use this equation to find the angle of C.
By cross-multiplying sine of C times 15 and sine of 30 times 20, we get 20 times sine of 30 equals 15 times sine of C.
20 times sine of 30 is 10. Divide both sides by 15 to isolate sine of C, and then you get that sine of C is equal to 2/3. Now, take the inverse sine of both sides, and you get that angle C is approximately equal to 41.8 degrees. We can round that to 42 degrees.
So now you know that the angle at City C is 42 degrees and the angle at City A is 30 degrees. Add these together and subtract from 180 to find the third angle at City B, which is 108 degrees.
So now James knows the angle he has to fly at if he's facing towards City A. He will need to fly at 108 degrees to the left. Daniel, however, still doesn't know how far away City C is.
Let's find out.
Alright, now we use this law of sines again to find the length of segment B. We plug in what we know and we get this equation. Then we cross multiply and get sine of 108 degrees times 15 is equal to the length of side B times sine of 30 degrees. Then we multiply 15 times sine of 108 degrees and get that sine of 30 degrees times B is equal to about 14.265. Then we solve for B by dividing both sides by sine of 30 and get that side of B is equal to 28.5 miles.
Now we have everything we need to know.
Yep, now we know that Daniel has 28.5 miles to fly to City C, and James needs to fly at an angle of 108 degrees to the left when he's facing City A.
Yay!